All right. Good. Good. So again, let's keep the session interactive. Keep asking questions, and we have ample amount of time. Don't worry about it. And in case the time is not sufficient, we might extend the session from 11 session to 12 sessions. But that's not a excuse for skipping something or skipping your questions. All right. So happy New Year to everybody, and welcome back after a long holiday. It has been 2 weeks since we had last session. So, all right. So we had discussed in PIG few things like. So are you guys able to hear me? Abhishek, Ajit, Manish, Anna, Vishnu, and I'm wondering why are there only 5 people today. All right, good. So keep the session interactive. Keep asking questions. And so last time we talked about PIG. We even talked about how to use PIG's external functions, and we talked about flatten. We talked about PIG calling external functions. We talked about how to integrate with the legacy code, and so there is something called PIG for each nested. Okay, so we talked about for each clause in PIG, which basically does iteration over the record. All right. For each is more like you go record by record in case you want to change anything. You print it on the screen. I mean, you manipulate the record by record data set. All right. Now, there is a very frequent requirement that while we are iterating, we do the grouping. Okay. So, for example, say in a given data set, like this, what we want to do is we have to count the distinct names in each city. So we are given the data set containing two columns, city name and the person name. And in each city we just have to count the distinct names. For example, Bangalore has got Vivek and Sandeep as distinct name, and New York has got only John, which means that a result we need is Bangalore 2 and NYC 1. All right. Okay. So what we do is first we did a grouping. Okay. Grouping is pretty straightforward. Now, while we were doing grouping or while we were iterating over each group, all right, then itself we could do a distinct on top of it. Okay, so we did grouping on Bangalore. So for each, the records we got was mm, for first record we get Bangalore, second is New York, and for Bangalore there will be three elements in that. Now instead of again creating new data set or doing it by yourself, Pig provides you Big provides you a functionality to operate on this new data set. Okay. For each key, we have formed a new data set. So we can actually apply. most of the functions, such as further group by onto this data or further aggregation onto this data. So like we discussed about distinct, and we are able to use distinct over here, right? The way we have applied group on a data set, in the similar fashion we can apply distinct on the data set after, on each of the groups. Okay, now if you remember, we talked about distinct earlier. We talked about distinct earlier. Let me just, yeah. So here we did a distinct on symbol on one data set which was generated by for each, right? In the similar fashion, we can inside for each itself we can use distinct. Okay, so for each, whatever whatever we result we have got, we can pick a particular column out of it. What does it mean by picking a particular column? It basically means all the records which are uh, I mean basically after grouping whatever you got, it will prepare the distinct out of it. So distinct of Sandeep and Vivek is Sandeep comma Vivek, and then we can do a generate and do a counting. Okay, so this is a good syntax in the sense that we have nested our data operations. We are iterating over records, and for each record we are applying further processing on on each of the records. Okay, so these are quite useful in the sense that they make it possible to process the data using pig directly, rather than you inventing your own distinct operation on an array. Okay, so this way for each is quite useful, and you can use almost all the records. You can use another for each inside another for each. Okay, you can use in for each inside another for each, and then you can use generate, and that's why it's called for each nested. Okay, now okay, there's some question. Why is the group by column named group? All right, okay. So whenever you do, whenever you group, whenever you group a record, by default it creates one more column which is generally the first column. Okay, which based on the column which you have grouped. Okay, so it creates a fresh column, fresh uh, I mean record, which contains first column or the first column as the group name, and rest of the column remain whatever they were there in case of people. So let me give you an example. So let's say in case of a word count, so we have got Sandeep and one, Giri and one, and let's say Anna as one. Okay, now when we, so let's call this data set as names. All right, whenever we say my groups equals group names by, and let's imagine for time being names is essentially name and count. Okay, group names by name, that's all. All right, just wait for a minute. Okay, so when you look at groups over here, you will find that, or let me just do it for you, okay? All right, now Giri, and let me just, all right, so we have got names. Let me just delete the last line. And I'm running the pig in the local mode, and we call it names equals load names, and we say dump names. So we have got this, and my grouped names equals to group names by, okay. And if you see my, right now, as you can see here, I think I should have used some more data. Let me just open names again and put Sandeep once more and put 2 over here and put Anna and 20. Right. Now, now you can see that big minus x local names equals load names, right? So what does load names does? Can you see my screen clearly? All right. So when you say names, and now we say G equals group names by $0. All right. Now if we say dump G, what will happen? It will show us all the records grouped together containing the same name. All right. $0 refers to the first name, as we talked earlier that while loading a file, you don't necessarily need to give the column names, although it's optional. If you don't give necessarily give a column name, you will have to refer the columns by indexes. Right. Okay. So let's say describe G. Okay, so G says that there are two columns in this. First one is group and second one is names. Okay, hope it is clear now. So it has converted our names. Yes, you can rename. So you can say the way earlier day I did was my group, right? And I said group by something. So it's up to you. Okay, but by default these names are something which group by decides. Okay, if you notice, then every group by generates two columns, two fields, you can say. First one is group. It's fixed, always it creates a group by the name of group based on on what field you group by. Second is the name of the data set which you are grouping. So we were grouping names. So based on that, it has created the second field. And what is the second field? It's a bag of tuples. You can see clearly it's a bag of tuples. Okay. So G is a bag of tuples containing first field as string, second field as another bag of tuples. All right. Or you can think of it like your database table. G is a table containing first column as string and second column as another table. Okay. Or another array you can think of in the name if you want to. Okay. So now you can see clearly that G is our group. Alright. And when you do for each on G, okay. So when you do for each, let me say we call it G1. No, group name cannot be changed. Group name will be based on what field are you grouping. And second name, so this group is fixed. No matter what name have you given to your tables, the first column is going to be hard coded as group. Okay, while second column is going to be based on what table are you, what data set are you grouping. Okay, now when you say for each G and and then you put brackets, then you can basically do, I mean, say distinct names equals distinct distinct, and you can say G dot names. Okay, so as you can see that you can basically refer to your table, uh, refer to the name, if you see that. Okay, not like that, names dot G dollar zero. Okay, and then you can do a generate 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 what? G dot generate group, comma, count of dn. All right, this is what happens. You have to do a count as capital, and then you can say dump g1, right? What is it counting? Oh, we are actually doing a wrong thing here. We are actually doing a wrong thing, because distinct of something, what we are trying to do is we are basically computing one number, and that's not what we wanted to do. All right, so actually I picked an example to demonstrate to you a for each, and I ended up showing you this. All right, so basically, should I run you, so is this example clear to you, or should I demonstrate to you? I was actually trying to demonstrate a group by the columns. Okay, so is this for each nested example clear to you? No. Okay, all right, so let me then, okay, so looks like it's clear to everybody. Let me uh, go through one question. All right. Can you please brief which part of this program goes as map and which part goes to reduce? Good, good. So, did you mean to say, Ajit, the I missed that part. So, did you mean to say when we did a simple counting, or let's say group by, only group by first? Okay. So let's take this example. Let's take this example first. Yeah, this can be applied to the examples given to you in exercises, but I don't think there is a need to apply for each nested in any of the exercises which were given in the last session. Okay. Now, let me just describe this part to Ajit. So, to be honest, it's a quite a tricky exercise to be able to convert a given query big statement into MapReduce. Okay. Now let's take the case of this one. All right. So we have got a table called names, and we are doing a grouping over here. And afterwards, what we are doing is we are just doing, let's say, okay, sum equals, let's say this one. Okay, c equals to for each, for each, for each my groups, and generate group and count of, okay, let's say, yeah, count of c. Okay. Now what all happens in this case, let me just turn off my phone. Now, what happens in this case, if you look at it closely, if you had to do the same thing using MapReduce, what it is going to do is take the input data set, and as part of map, it will be giving out the name as the key, okay, name as the key, and the whole record as the value, okay, whole record as the value. That that's what map will be doing. Now, in the reduce function, in the reduce function, I mean, when pig will be converting into reduce, what it is going to do is take for each key, okay, for each key, what it is going to do is return count of value.c. Okay, so this is what is going to be as part of map and reduce process. All right. Similarly, when you are going to use for each nested, there are many different things happen. Okay, so in this case, most of the for each for each and then bracket part happen as part of the reduce phase. Okay, most of it happens in the reduce phase. All right. So whatever this part is going to be inside the brackets, it is going to be inside the reduce phase. And pig guys have also worked upon it so that most of this portion can also be moved out of reduce and made part of map. That is little bit advanced exercise, but if you think about it, if you had to do the same thing, what all things you will do, you will be able to figure that out, right? So most of this goes into the reduce phase, while this portion is a map. Okay, this portion is a map where it's just defining that group my data by this particular column. Essentially, it's telling that this is my key and this is, and rest of the whole data set is my value. Okay, I mean all of the rows, each row is a value, while the key, I mean the city out of the whole row is my group key. All right, so that's how it happens. Yeah, most of the aggregation happen. I mean, all of the aggregation happen in reduce phase. You are right. Great, great. Hope I'm clear. I did not confuse you, Ajit. All right, good. Now, now there are few interesting things, okay, which you can take further control of. Should it be count C or count names dot C? Let me look at it. Just a second. Which one we are talking about? We're talking about this one, right? Or we are talking about this one, right? Yeah, it has to be names by C. You are right. It has to be count names dot C. You are right. For brief, I did that. Right now, because if you notice that this one will have two columns. First one will be named as group, and second one will be named as names because we are grouping names. Okay, and while referring to any of that, you can, I mean, referring to the fields of name, you can use referring the fields of names, you can use names.c. Okay, now, yeah, so this is an interesting part. So there are many reasons. So the way, okay, let me take a step back. The way pig was doing a join for you is based on equality of two column values. Say you have table 1 and you have table 2. Pig was trying to join them based on a particular value. Okay, on equality. Not unlike your SQL databases where we can say select from table 1, table 2, where a dot this table 1 dot this column is lesser than table 2 dot this column. Okay, that's not something you can do with pig. Okay, you can only do equality operation on pig. And why so? Because on whatever field do you do equality on pig, you basically pig basically under the hood creates, in the map phase it creates the record having the key as the column on which you wanted to join. Okay, so whenever we are joining table 1 and table 2, on on key 1 and key 2, so key 1 from the first table becomes the key for the map phase, as well as key 2 from the table 2 becomes the key for the map phase. And as we know that automatically the Hadoop will group them by the key. Therefore, all the records from both the tables having the same key will come together. So effectively making it possible to join two rows, two tables based on a particular key. Okay, so that's how it happens. But now sometimes it so happens that that when we are joining two tables, one table is really, really small, very small, okay, such that you do not require a reduce phase to join two tables. All you need to do is go through record by record in one of the tables, okay, and load the other table into the memory. And while you are going through each each record itself in the map phase, you are able to quickly translate or join the two data, okay, because you have loaded the second table into the memory like a hash table, and you have quickly joined it instead of waiting for the reduce phase to join it for you, okay. Now take a case of when do you require this such kind of functionality. Say you have a huge humongous table called name and where those people live. Now you are asked to translate this table into into a table containing country code as well, okay. Okay, so you are asked to translate this table into a table containing code instead of country name. You just have to replace a code. So can somebody tell me how many countries are there quickly, roughly, in the world? Say 100. Okay, so 100, keeping this information about 100 countries against a numeric country code is not a big deal, right? It's not a big deal because it will take at most how many I mean 200 bytes or 300 bytes of information, which is a very small data. We can keep it in the memory, okay. So what we can do is, while reading record by record in this table, we can simply look up into the memory which we have loaded and is quickly say that this is the country code, instead of going through the whole map reduce phase, joining these two tables. Okay. Why? Because the second table is extremely small. Extremely small. We have 1 billion entries one side, and we have, you know, the country to country code is like 100 tables, 100 entries closely, hundreds of entries. Okay. So, in such circumstances, ideally, what would happen is when you join these two tables and you are trying to join on basically country, what will happen is in the map phase it will spit out the country, I mean the data based on country as the key in both the cases, and then it will group them together, and in part of reduce phase uh, we will bring the data in the format which which we want, right? So instead of doing it that way, because the second table is quite smaller, okay, what it helps you doing is that you basically load the second data into the memory and replace the values while you are processing the first table itself, okay, in the map phase itself. So for these kind of circumstances, as a thumb rule, whenever you have one huge table, one very light table, what does it mean? A table which can be loaded into the memory without fear of running out of memory space, right? So if you have such kind of scenarios, okay, when you have some such kind of scenarios, always use the fragmented joins, okay. So nothing great about it. It just whatever join you had written against the table which is smaller, just say using replicated. So here the country code CC is our small table, and therefore we are using replicated against CC. Okay, had our persons been smaller, we will write here saying using replicated. Okay, sounds cool. So as a thumb rule, even if you do not want to get into all of this cycle of MapReduce, you can quickly say that when you are joining two tables, one of them is very, very small, then just use a syntax called using fragmented against the smaller table. And it will make your joins really faster. Okay. Everybody clear about fragmented joins? Although for using it you don't require any further more syntax. All you require is just say using replicated. All right, should I move ahead? Good, good. Now the other scenarios, so these are all optimization steps. Remember this is an optimization step. This is also an optimization step called for each nested. Although it makes your life easier also syntax wise, that's also assist in productivity. Now there are scenarios when you encounter skewed data. Okay, say for example there are too many values for a key, for a particular key, while there are too few keys for another key. Okay, that kind of data is called skewed. All right, if your key is gender, okay, so there are chances are that the values for each gender, male or female, is going to be fairly equal, fairly equal, and therefore the data it the data would not be too skewed. But if you talk about people, and you're trying to group people by the state they live in, okay, by state they live in, for some states, say island, or for some state where there is a very small population, the data will be too few, while for some states like New York, the data will be too high. Okay, a difference of 1 is to 1 million. Okay, in those cases we say that the data is really skewed. Okay, so when you have too many values for one particular key and too few values for another one, in those too few as in the ratio of 1 is to 1 100,000. Okay, in those cases we generally say that our data is skewed. And when you're dealing with big data, these circumstances are very, very popular, very, very common. Yeah, so if you take a table and you try to group by a particular column, and you realize that for some values of in that column, there are too many records, and for some values there are too few records. In those cases we say that our data is extremely skewed by this particular column. Okay, now If you encounter such kind of scenario, what will happen is when you in the reduce phase might further require a map and reduce thing, right? Because you may not be able to process all of the values on a single machine because your data is too skewed. You have to process 1 billion record on one machine because the reduce always runs on a single machine for a particular key. Okay, so if your one particular key has got 1 billion values which need to be processed in a single reduce phase, in those circumstances your whole process may not work, your whole map reduce may not work. So under the hood, because big uses map reduce, these circumstances will haunt and actually haunt all of the pig developers as well when they are trying to group something by a key where the values for a particular key are billions and for another key there are few tens or maybe few numbers, okay, in a single digit. So in those cases what you do is while joining you always mark the other table, mark the join as skewed, okay, so that while joining itself, when it's joining the two data sets, it will ensure that for reduce phase itself it will trickily distribute the distribute the load in a different fashion. Okay, so there is something called skewed joins. If you remember, i i I have an example. So we when we were discussing our problem here, okay, so this one is specifically, if you remember this problem, so in this case, for some word like are or is or to or you, the values are going to be too high. Okay, values are going to be too high, and these are basically, if you try to do a map reduce such that your values are too many, it may not work. And basically what I mean by here is that whenever you're joining two tables and you're joining on a particular column, you're joining two tables, say city and users, on basically, so city information, what are the cities across the world, and population, people across the world, and we are joining based on city. So there are high chances that for a city there may be few users, for another city there will be too many users, and such joins you generally marked as skewed. Okay, and when you mark it as skewed, pig will take care of distributing the load uniformly by doing couple of tricks. Okay, so that's how you handle your skewed data. That's how you handle the skewed data. But before doing this, you'll have to ensure that your data is really skewed, because using a skewed puts a little penalty on the performance, but it makes it possible to makes it possible to handle these kind of circumstances. All right. Now, if you have the other interesting aspect, what pig provides you is joining sorted data. This is not uncommon, this is frequently common. Like for example, when you did grouping, or then you did for each and generated another data set, your generated data set is always sorted by the group on which you grouped. Okay, your output is sorted by the group field. Okay, so you already have got sorted data, right? So, and you are trying to join this data with another data which is sorted on the same key on which you are trying to join. In those cases, it makes a lot of sense to tell pig that, hey, this data which I'm trying to join is already sorted, and therefore pig does not need to do anything special with it. So it will basically utilize this property of your data, that it is already sorted, instead of sorting it again. Okay, instead of sorting it again, it will just utilize that information that your data is already sorted, and it will give you the results. So when you're joining two data set and you know for sure that your data is sorted by the field on which you are trying to join, then you can mark it that use merge. Okay, you can tell pig that, hey, my the both of these tables are already sorted, so just merge them instead of again sorting and then trying to figure out. Will join re- result be sorted by default? Yes, the joins result will be sorted by the key on which on which you have joined. Okay, by the field on which you have joined the two tables. All right. Now, similar to skewed, similar to skewed, merge, replicated. So we talked about replicated. We talked about replicated or fragmented join. We talked about joining skewed data, and we talked about merging. So these were like optimization and assisting pig to take correct calls. Okay. So similar to that, we have got co-group. Is skewed and merge associated to one table versus second? S- No, I didn't get the question. So skewed and merge both are related to join. Okay. In one case, if your data is to uh, varying in number of fields, okay, in those cases you use skewed, and for merge, no, it doesn't. No, it doesn't. All right. So similar to those three things, the fourth point, which I mean, in which Pig try to help you in optimization and making it possible to churn certain kind of data, it provides you co-group. Okay. So co-group is essentially grouping and then joining, grouping and then joining. So in this case, you can see that first it joined the data by animal, and then it grouped them by the same field. Okay, so it's quite often in when you deal with data that you first join the data by a particular column, and then you you group the data by the same column. Okay, it's quite common. It's quite common. So instead of sorting the data twice, one at the time of grouping and one at the time of joining, Pig helps you doing it only once using co-group. Again, this is an optimization step so that you do not have it doesn't have to sort the data twice. Okay, so when it's joining the two tables, it's anyway sorting the data, and then after again, if you are trying to group on the same column, you do not have to do that, because it has already because it has already sorted the data. Okay, so it doesn't, while grouping, it doesn't require to sort the data. Like for example, here when we say co-group owners by animal and pets by animal, so we have got owners, we have got pet, and we are saying co-group them, which means join them and then group them by animal. Okay, first it did a joining, which means for cat we got Adam, and for cat from this side, we got paws and whiskers, and here we got Alice. All right. So okay. So I'm actually reversed it. So basically, it first groups them and then joins them instead of first joining and then grouping. So it first groups them and then join them. Okay. So here you can see that if you group this table, if you group this table, let's say for cat, if you're grouping it by cat, you'll get for cat. Okay. You got Adam comma cat, Adam comma cat, and then you will get Adam comma Alice comma cat. That's what happens when you are grouping the first one. So if you see, if we say group owners by animal, will result in this one. Okay. Similarly, when we say group pets by animal, will result in what? Having these ones together. Okay. We say cat. All right. We got group pets by this. Now, when you're joining these two data set, this one and this one on cat, okay, let's call it X, let's call it X, and let's call it Y. Okay. Now, if you try to join them together, join X by animal and Y by animal. Okay, so what will you get is for cat as this, we have got two. Okay, okay. So we basically, although it will be a little more complex than what we're talking about. Okay, so basically, if you try to join that, you will get Adam, cat, and so on. So whatever we have listed down here, that's a similar kind of thing we'll get. Okay. All right. So whenever you have to group the elements by by a column and then join the two tables by the same column, then in those cases co-group is a better and more succinct as compared to the other ones, as compared to doing it using group and and then joining them. The other benefit it gives you is here I would be I would be basically doing, if I have to do this, I'll basically doing using merged. Okay. So that because I know that both of this data is actually sorted already. Okay, so this was another step, another optimization step, and instead of avoiding all of this hassle, you could use core group. Yes. So core group will, yeah, core group is essentially grouping and joining the two tables on one particular column. So grouping will also happen on the same column, joining will also happen on the same columns. And in a lot of cases, you will notice that this is actually quite frequent. This is actually quite frequent. All right. So that's what we call grouping. Yes, curly braces are for bag and brackets is for tuples. You're right. All right. Now, similar to Oracle and other databases, Pig also provides you union. Union essentially is like concatenating two set of records. Okay. So if you loaded A and you loaded B, and both of them, I mean, so C will be basically all records from A followed by all records from B. Okay. So if you have got A as, say, Sandeep Giri and B as, okay, some N1 and N2. All right. So if you say union A comma B, what you will get is Sandeep Giri, okay, and N1 and N2. This is what you will get. So union A and B on, okay. So this is quite straightforward. This is quite straightforward. But in case you want to join on schema, all right. If you want to join on schema, say A has got two columns, name and age, while B has got two columns, name and name and gender. Okay. Now under name, let's say we have N1 and we have 10, and here we have N1 and we have 20. Okay, and we say union A comma B, what you will get is N1, 10, and okay, so you will get three columns in the result: name, age, and gender. So here in the first case, this will be empty, this will be null. Okay, while in the second case, it will be again N1, and then it will be null, and gender, let's keep it M here, and we'll have this. Okay, so when we are union on schema, this is what you will get. Okay, so whenever you are doing a union in a state away, the standard way, union A comma B, you will get N10 and N1M. This is what you'll get. Okay, while if you do on schema, this is what you're going to get. This is not something you'll get in the output. This is just for your sake. Okay, sounds good to you? No, no. No, Anna, this is not joins because had it been joins, then for one particular record, we have not specified that we are joining on this column, that column, or no, we are not doing that. We are just putting data on top of another. That's all. There is no joining happening. Joining would require that we are joining on a one particular column, and both these records say we are specifying name, so n110 and then followed by n1m would be part of a single tuple, not two separate tuples. Okay, so everybody is clear about union, because this is something confusing to lots of people. That's why I've taken this example. Great. Ajit, Manish, Valentin, Malikram. Great. So that's what is union all about. Okay, and now let me ask you a very, very simple question. All right. If you had two tables, table one containing nouns, okay, and noun is like she, he, or let me say table one called adjectives, adjectives, okay. Table one called adjectives, which has good, bad, nice, okay, while table 2 called nouns, and we have got, okay, and okay. Now what we want to generate is all possible combination. Let me just reduce some data to make it easy for us. What we want is to generate all combinations like good person, bad person, and good cow, bad cow. All right. This is what we want to generate. All permutations of these words, which is essentially table cross table 2. This is a cross product of table 1 and table 2. Right? Now, what is it that you generally do? Can anybody tell me? What will you do? You're giving two tables, one table containing adjectives, other table containing union, containing all nouns. What you want to generate is the whole combination of adjectives versus nouns. So what would you do in general if you have these two tables in database? What is it that you do? Anyone? I'm talking about the standard database. So you have got two tables, one containing adjectives, other containing nouns. What you want to generate is all combinations of adjectives and nouns. Like in our case, we have got adjectives good, bad, noun, person, cow. So the total combination is good person, bad person, good cow, bad cow. Cross join. Okay. Anybody else? Anybody else? Okay. Join without an ID. Good point. Very good. Right. Right. So ideally, in the standard scenarios, select star from adjectives, common nouns will give you the desired output. Okay. This will give you the desired output. So whenever you're joining without a column, you will get the result containing adjectives and noun. All right. Now, sounds good to you? Now, if you had to do the same thing using pig, what you will do is use a cross product. Why? Because this kind of syntax where we are not specifying on what field are we joining, okay, we always have to specify a column on which we are joining two tables or two data sets. We always have to specify that in case of pig, and therefore this kind of joining is not possible, and that is why cross product has to be, I mean, they had to give you another syntax. They had to give you another syntax to do this. Okay. So cross table 1 comma table 2, and then you can also specify parallel on how many machine you want to do it parallelly. All right. So that is something called pig cross, and since pig is quite often used as a reporting tool. So giving a parameter like start date, end date, for how many days you want to run it, for which department. So all those kind of parameters need to be passed to your pig script. So if you remember, you can execute any script by putting all your command in a file, and then running a command like pig my file dot whatever extension you want to give. Okay. So if you have a daily.pig, you can say pig daily.pig. That's all, and it will run that script. Okay. In case you want to pass argument to your script, you can specify those arguments using minus p, like pig minus p, date equals to this, and daily.pig is your script name. Okay, this is the parameter you are passing it. And inside your daily.pig, you will have the query in this format where you will be referring to the parameter using dollar. Okay, so it will basically replace this with the value you are going to pass from the command line. For each table 1, okay, okay. Yes, you can do that, Anna. Let's try it out. I haven't tried for each inside for each, but I would definitely give it a try. Okay. Theoretically, you can do it, yes. Yeah. So running a script, instead of first launching pig, you basically launch it like pig and script. And you will not see a grunt when you are running a script. All right. Now, there are some circumstances where you have got too many parameters. So instead of piling all the parameters on the command prompt by specifying minus p as a parameter, you can specify all the parameters into a single file, and then refer them refer them wherever there is required. Also, inside the parameters itself, you can reference the other parameters which are defined before a particular parameter. For example, we have date equals dollar year, dollar month, dollar day. Dollar year, dollar month, dollar day is already defined above. Okay, and then you can execute it like pig minus param file, and then specify the file in which you stored all the files and then run it. Also, you can put a hash to define the comments. Sounds good? All right. So there is a way of splitting a single file into multiple data sets. Okay, there are so we talked about joining, where we could join data from multiple files together. In the similar fashion, you can use pig splits to split a huge data set into data is other smaller data sets, which can be joined to with each other or with other data, and also be stored in different files. Okay, so they will act like a data set as if they are loaded separately using load command. All right, so for example, for example we have got we loaded web logs as these call three columns, and we are loading web logs as three columns. Okay, all right. Now we can split w logs into three set of three or n number of data sets by using a split command. Now, here what you need to notice is April 3, April 2, or April 01 are not mutually exclusive. They are not also they are also not covering the whole data. So it's like if else condition. If your record has got timestamp below this value, put that record in this. Also note that the same record can also be put into the April 2 and April 1. Okay, so you can generate as many possible splits out of one data set as you wish to. Okay, so you can notice that all the data records which is on the 2nd of April would go in April 02 as well as April 03, right? While all the records which is beyond which is which is beyond April will not be loaded anywhere. So we dropped a lot of records as well as we replicated few data. Okay, and that is how the split works. So one single record got can also go to multiple legs. These are three legs, and one record could also be dropped out. Okay, and there is something called non-linear execution. Okay, so as you saw in case of a pig, the actual execution started when you did dump or when you did you know the actual execution started when you did store or dump, right? So the execution was not really linear. The execution instead was the execution instead was non-linear based on your requirement, the data flows. Okay. So all of your work is actually unlike your standard programming where the data complete flow is linear from top to bottom. Here it's bottom up. Okay, whatever is needed for one execution, it will do those things, right? Say for example, we are joining two data sets which are being produced by two sets, and before that, those two sets are basically dependent on a split, right? So here, when you're joining, all these records will come through two portions and will be joined together. Okay, and you should note that this split process here is nothing but a single map which is doing the job for you. This is a single map which will be doing the job for you. Okay, and sometimes it also figures out in case April 03 and April 02 does not need to be can be handled in a single map or different maps. Okay, so it will try to absorb a lot of computing. Say you are doing some map operation on April 03 after a couple of steps. So those steps could also be absorbed into the split itself so that it doesn't require to go through the same records again. Okay. So if you are doing after a split, if you are doing for each here, there are chances that some of the for each will be absorbed into the same map phase which is doing the split. Store basically stores the data into the disk. Okay. All right. Okay, I missed a lot of question. Let me. So first question, Abhishek's question was that how do I get formatted output in Pig? Okay, so there are multiple ways to get the formatted output. First, you use your for each to do all sorts of churning. But in case you're not happy with this format, you'll have to use output formatter such as CSV, pig catalog, and then you mention that I want in CSV, I want in this format. And in CSV you can mention that I want the output to be separated by pipe or comma. Okay, in case you don't like this any of this, you can also use a JSON output, which will be stored in a file, or you can use the standard pig one. Okay, so that's how you generally format the data. So Abhishek's next question is that can we make splits work in mutually exclusive way? The quick answer is no. Okay. Can all data be kept in HDFS? Okay. So let me first finish the first answer. So no, Abhishek, the split does not enforce that kind of a boundaries which are mutually exclusive. Split is more like if else conditions or switch case statement. So your logic has to enforce that part. Okay, your logic has to enforce that part. Okay, can all data be kept on HDFS? Yes. So whenever you're dealing with pig and you're manipulating the data, right? So depending on your load statement, whether it's using your standard pig loader, or is it using H-based loader, or is it using some other loader, your data will be picked up from there. Similarly, while while storing, you can either use pig loader standard one, which basically talks to HDFS in case you are running in the live mode. In case you are running in the local mode, it deals with the local files. Okay, so in case you are running pig normally and you are not specifying how to load the data, it is going to take it and put it on HDFS. All right. Okay. So store basically stores the data onto HDFS file if you are running in live mode. In case you are running in the local mode, it will be storing on the local file. All right. Is split something similar to regular split function? So generally regular split functions split a data into mutual exclusive way. It doesn't do that. So you cannot take that analogy. When I used pig storage, comma for CSV and tried dump command to check the output, it was not correct. The data had a comma within the message. Had a comma. How do I handle this? Okay, okay. All right, all right. So you use pig storage to load or save? Okay. Yeah, in those cases, the CSV loader is not so, um, you know, so robust that it handles the CSV standard format. So generally, the way CSV format works is in case your data has a comma, in case you are trying to store name, say name is Sandeep, comma Giri. Okay, and and age is some 34. Okay, now if you try to form the CSV out of it, so CSV in the form of name comma age. Okay, so the idea generally is that you keep the comma like this and then put age. So this is the standard which is there as CSV format. So I guess pig would be following this kind of format. If it is not, then we need to figure out how can we handle this data, whether we can figure out a pattern, whether we can use a regular expression to split. So that way. Okay. You might have to use a regular expression. Okay. Okay, so this worked. Even if you do not specify using pig storage slash t, then also it will do the same thing. By default, the separator is slash t. Okay. Let me have a look at your data. Just drop me an email with the data that this is my data and this is the command I'm trying to use. I'll be able to help you. And in case it is useful to all other people, then I'll put it on the forum. Okay. All right. So let us take a quick break of 10 minutes and come back. That basically completes our discussion of pig. For further details, you go through the 13th version, 0.13 version of pig. And if you want to go through details of custom load function, you can go to this page. And that should be good enough. All right. So, yeah. So that's pretty much about pig. That's pretty much about pig. All right. So I'll take a break for 10 minutes. Hi, I'm back. Are you guys back? All right, let's start then. Great. All right. So, so far we talked about, in the beginning, we talked about what is big data, then HDFS, then the MapReduce, and then we talked about pig, and we are going to talk about something called Hive. All right. So the pig session is over now. You can go through exercises which were given already. Those should be sufficient, and try to finish all of them. All right. Now, with respect to Hive, okay. So, although Hadoop is great, Pig is great, but there is still lots of people who do not know about Hadoop and Pig. They do not have too much of time to learn all of these new technologies. So, but they have a demand to handle their big data. Okay. So people already have a lot of data lying in their relational and SQL infrastructure. And there are a lot of SQL users, database designers, admins who are quite efficient with SQL. So the question is, can can we leverage that kind of knowledge to onto a big data platform? Can we help them out so that they can handle big data? Okay, that's where the hive comes into picture. We all know that coding something in MapReduce is too time consuming and lot of repetitive logic is there, and sometimes it becomes difficult even for the developers to do very simple data churning using MapReduce. All right, that is the reason why pig was invented, and a simple things like join three tables and group by after that, and then put some filters will take a lot of time on MapReduce. So for lot of data churning parts, MapReduce is generally not an option. Okay, so you are generally left with two options: either use pig or hive. Now it's your convenience level which one you want to go with. If you are very convenient with SQL, you would like to probably go for Hive. If not, you will like to go for Pig. Okay. Pig also helps you giving far more efficient queries as compared to Hive. Right. Now let's go ahead and discuss further. The value proposition of Hive is essentially it is very well suited for data warehouse application. Okay. In the circumstances when you have to churn relatively static data and you do not need a very fast response, you would like to go for Hive, specifically when your existing projects are in SQL. Okay. So similar to like standard your Microsoft SQL, PL SQL, Hive provides something like a Hive QL, which is very, very close to the standard SQL. Okay, all right. Now, since Hive is provides you SQL and Hive has to handle the data which might be unstructured, it has to store the metadata, and that metadata is stored in metastore. Okay, all right. Also, it allows you to query the files located in HDFS. As Pig was also helping us loading the data from HDFS, it helps you load the data from HDFS, it helps you load the data from HBase, and it helps you load the data from other places. All right. Now, so this is the general value proposition of Hive. There are few limitations of Hive. Okay. The biggest limitation you will observe is that there is no syntax for insert, delete, and update the records. Okay, you can create a bunch of records by reading the data from one table, then churning them, and then putting them somewhere. But it's not possible to update, delete, or record the data using Hive. At least till this point, it was not. In the next version, which they are launching now, it seems that they are providing update, insert, and delete. Okay, but it can definitely generate new tables. Okay, those who have used select star from table, insert into select star into a table, that kind of syntax Hive provides happily. All right. Also, the online transaction processing, which is OLTP, is not a suitable use case for Hive, and the reason is that the queries of Hive has higher latency. Okay, the latency is also coming down to now less than a second in the newer version, though. So queries have by default higher latency because Hadoop MapReduce takes time. Every query gets converted into MapReduce by Hive and then sent to the Hadoop. And since Hadoop take has a latency period of launching a query, right? So since Hadoop has this latency while launching a job, that makes Hive also slower. Okay, so there is a startup overhead, and therefore Hive is not great for online transaction processing. These are the limitations. This is great when you have to when you have to maintain an existing data set and mine a data set instead of alter a data set. So if you have a data set which is maintained by some other process and you just have to mine it or churn it, then you can use Hive and you'll be happy about it. All right, great, great. Now this is the general architecture diagram of Hive. So you have got Hadoop, you have got Hive, and then you have got other clients. Okay, you've got other clients like Hue, Cubole, and others. Now inside Hive, inside Hive we have got the at the bottom as most level it is driver basically compiles and optimize and executes any of the code on top of Hadoop and HDFS. Okay, it basically whatever query you give, it compiles it optimize it, then executes it on Hadoop. Okay, it forms the map reduce, it talks to DFS, it does a lot of things. So that is the role of a driver. Then there is something called metastore. Hive stores the data, a lot of metadata into metastore, and you can talk to driver or Hive driver using a command line, and then you have got what do you call this is command line interface, and this is web interface, HTTP web interface, HWI, and you have got JDBC interface, standard from Java, and ODBC is another one. And JDBC, ODBC, and other APIs, they all talk to the driver using something called thrift server. So server is a service platform, basically a service layer, in which you define your services, you code your services in a particular language, in the intermediate language of thrift. Okay, that gets converted into all possible programming language, hundreds of programming languages available with thrift. Okay, so thrift is a very general purpose server or general purpose service oriented framework, which helps you create the service, uh, which is to be accessed across multiple programming languages and remotely. Okay, so that is thrift server. So at the heart of it there is a driver, and then there is a meta store, and all of this is being accessed either from command line, then web interface, then sorry, HWI is Hive web interface, and then and thrift server. Thrift server can be accessed from hundreds of programming language. Okay. Now there are these layers which basically talk to Hive using either JDBC, ODBC, web interface, or command line interface. That is how people communicate to Hive. Okay. So when we are going to talk about Hive, we are going to go with CLI. Okay. You can also use web interface via Hue. Okay. Now, just to give you a little bit taste of how would it look like to do to basically do a word count in. So let me just take this case. So how would you do the word count using SQL is this one. So you copy the data from one location to another, and then this is that our big text file in which we did the word count. And then you load this data into table called docs, and after that you create this. Okay, so what all it is doing, first it is splitting the data by new line spaces. Okay, and after it has splitted the data, it is basically generating word and numeric 1, and once it has generated that, it is grouping the data by word and then summing it up. Okay, counting it basically. All right, so after it has splitted the data like this, it is basically ordering by the word and grouping it. After grouping, it is just counting it, and then storing the results into words underscore counts. Sounds good? Sounds good to you? All right. Don't get intimidated if you did not get this. Don't worry. Okay. There are only minor differences. Malik. There are only minor differences. You will get to know them quite soon. All right. Now, the syntax is generally very similar. Only there are few specific syntax which we need to take care of, and we'll be basically only talking about those parts which require special treatment. All right. So, to get started, you can SSH onto Hadoop 1 or Hadoop 2 and then start Hive. You can either run Hive without any argument, which will basically bring you the Hive prompt, just like this one. We have got grunt here. Now let's say we say Hive. All right. So it is loaded. Now similarly, Hive minus E, and then there is a this query. Okay. This basically executes a query onto Hive. All right. Like this. No, actually. So again, similar to pig loader, if those .doc or .xls has provided you a Hive loader, then you can load those files. Otherwise, not. All right. Now let's have a look at this. So we have got Hive prompt here, and we can say something like create table a int, and there we go. Create table and my table. It has got one column. Create table, my table. No, this is correct, right? What is wrong with this? This is correct, right? I think it expects the case sensitiveness. Oh, right, you're right. So basically, yeah. So basically, we are defining a table called X, and then we are saying these are the columns. You can also say B as varchar. All right. Also, we can say describe X1. So it has got two columns. All right. Yeah. Thank you, Abhishek. Good. And so we can also say select star from X1. There's nothing is there, and drop table X1. Done. Good. So we just created a table and did a select star from the table and drop the table. It's as simple as that. All right. Now, so create command was this. All right. This was the create command. create table x, and we had a int. Sounds good. Anna? All right. Also, you can run the DFS commands just like you could run from the just like you could run from SQ from pig. You can also run the commands like this, as I'm able to run DFS minus ls. All right. And also, if you have an external so other than executing a script like this, hive minus f this, just note down this format, because this is what you're going to require in the case of your project. So you can execute a full script. You can write all your query, all your statements in a single file, and then execute it. Okay. So in order to, if you are on the hive prompt and you want to load a particular file, you can use source command just like you do in case of a bash script. Bash script also you can execute a script from inside of a command prompt by using source. Okay. The commands start with dash dash just like MS SQL, and also you can define the environment variable using set. Okay. Right. So it was not to do with the capital and lowercase. The problem was with respect to brackets. All right. Also, you can see this kind of you can refer to the environment variable this way. And also, if you want to execute the local shell commands, you can put exclamations. Okay. You could say exclamation cd. Okay. You can say, all right, and say pwd says this, and let me say cd dot dot. Oh, it's not letting me run. Oh, cd is not there. Great. Great. Now, these were the few basic syntax. Okay. So the data types is something interesting at Hive. It started with very small set of data types: tiny int, small int, big int, float, decimal, double. But every now and then, to be compatible with most of the databases, Hive keeps on adding more and more data types. Hive has been adding more and more data types quite often. For example, in point 8 version they added binary. Although they had boolean already, they had to add binary so that it becomes compatible and makes the existing users of various database comfortable. Okay. Varchar was added in point 1.2, though string was there from the beginning, and similarly char was added later on. So they're adding many kinds of data types continuously. So other than the basic data types, other than basic string, varchar, b- integer, long, other than those basic types, there is something called complex data types. Complex as in an array of other data types, and or it could be array of arrays also. It could be array of maps also, and there is something called map as the data type. Then you have got structs. Structs is basically a structure defined as column name and data type. Okay. Then you have got union. Okay. Structure is basically like your class, your C class. It's a collection of key value pairs. Okay. Key value pair can be in the key is the column name and value can be any other data type. All right. So when you are defining or creating a table, you can define either the basic primitive types or advanced ones. For example, in this case, we are creating a table called employees. Employee has got first column as a string, second as float, third is an array of strings which is subordinate. Subordinates are plural, so it makes sense to have it as array. And third one is map. Map is key and the value. Key is a string and the value can be anything, and so on. Alright. So struct is basically a complex object containing multiple key value pairs. So although map sounds like very similar to struct, okay? My map sounds like very similar to struct, but the thing is struct can only have those predefined keys. You cannot add more keys to it when demand. All right. So okay. So Malikram, actually I deleted my table. That is why you may not be able to see the table. Otherwise the tables are persistent. So Anna, what is the difference between primitive type versus data type? So primitive type, so data types are of two types, either primitive or complex. So data type can be anything. Therefore it says has map has key and value. Key can only be primitive type while value can be any complex type. Complex type or primitive type. I hope you got the idea. So when in the map it says map is basically key value pair. Key is primitive type, while value is data type. Data type means it could be complex or primitive, either one. Alright. After exiting Hive and re-entering Hive, the table seems to be unavailable. No, the tables would be there. Don't worry. Try again. Try again. Create a unique name. See if it is created properly, and then exit and then try to log in. I can show you. Although I have not raised any tables, so you can see show tables, and there are so many tables already available. Okay. Okay. All right. And the union type, I forgot to explain. Union type is the data type in which there is only a single variable at a time. Okay. So if we say union int val, say how should I describe? Okay. Okay. So when you expect one value, okay, only. Let me take a case of social profile. Let's say you have a field called social profile, okay, as part of union. ठीक है, union called social profile. It could be Facebook, LinkedIn, and Google Plus. So say you only want one profile only for per user. Okay, either Facebook, LinkedIn, or Google Plus, either one will do. In those cases, you define that field as union type, so that you only define it. It can only store one of the values, either Facebook, LinkedIn, or Google Plus, either one of the values. That is union type. So when in one field you are expecting only one out of multiple values, in those cases you define the data to be of union type. Okay, so it consumes the memory equal to the biggest field of the struct. Okay, a struct basically consumes the memory equal to the biggest field in the struct, because only one is stored, not all. All right, now let me go ahead. In example select, union is used against three fields. Okay, yeah. Hmm. So we have got three fields: Facebook ID, Google ID, email ID. So we expect only one value at a time. You cannot have two values at a time. That's the case where you use union for the optimization purposes. Right? Now, show databases I have shown you already. You can create a database and then you can say see the database and then you can use that particular database. Also, you could use this nice command which basically shows you the command prompt with the database name. So in my case, it's showing me, okay, show databases. If I say use Vera, so now the Vera database is shown in my command prompt. All right. Okay. You can drop the database, you can do whatever you want, but don't drop anybody else's database because people might be working on their data. Okay. So similar to SQL tables, you have got tables in Hive. You can say show tables, you can say select star from my table, then you can say describe my table, and then you can also say describe formatted my table. Okay. So let me see show tables. Okay, it doesn't have. I say asgiri and I say show tables. It doesn't have. So use default, use default, use default, show tables. Okay. Now if you see, show tables gave me a list of all the things. Now I can say select star from gprofit. Gprofit doesn't have any data. So I say select star from students, select star from students. Good. So we are able to get the data from students table. And if you want to see describe students, right? So we are able to see all the columns inside students. Okay. All right. Let me just grab some water and then come. Okay. Okay. Yeah. Yeah, actually, I went for taking some water bottle. So, so far everything has been just like your standard SQL. We talked about show databases, select star from table, the data types, and the basics of the database. It has got something called namespace. You can create our own database and start using it. So as part of exercises, whenever you're working, you always work in your own namespace. So create your own database and start working in that. Okay, so create your own database and work on that one. All right. So basically, the biggest difference between standard database and this one is these kind of tables. Okay, there are basically two different kind of tables. First one is managed table. Okay, and other one is external table. Okay, so managed tables are sort of internal tables. The life cycle is managed by Hive. Okay, since Hive is a data churning kind of a tool which helps you use SQL to churn the data. So it is supposed to churn the data which it doesn't even own. What does it mean by own? The data which it has no control of. It cannot delete the data. Therefore, it will be accessing various kinds of data. One is owned by itself or owned by somebody else. At the end of it, it has to give certain amount of output. Okay, therefore hive is comes up with the concept of managed tables and external tables. So managed tables are some tables which get deleted, which whose data gets deleted when you drop those tables, while external table is just like reference, or you can say pointer. Okay, it has only the metadata. In case you drop that external table, nothing happens to the data remains as such. Okay, so as a general practice, whenever you are trying to process some data, it's just you just want read only access, always create an external table. Okay, so all the tables we have discussed so far has been internal tables, right? So the biggest difference will you will keep in mind is whenever you're dropping an external table, nothing happens to the data. But when you're dropping and manage table or internal table, the data gets deleted. Okay, the data that's stored in those tables. All right. Now let's talk about how do I load my stocks. Okay, so we had, let me see, DFS LS S Giri, DFS LS S Giri. So there is, okay, so we what all we have here? Do we have New York Stock Exchange DFS minus LS? So let me again see if the data is somewhere. So we have got New York Stock Exchange daily here, okay, and DFS CD data. Oh, it doesn't allow you to do that. No, it doesn't allow you to do the CD. All right, now let me just see this. So what do we want to do is, all right. Now what do we want is, all right. Now we are trying to create a table called stocks by loading the data from our NYSE table, daily table, and it is an external table. For those who want to see where is it located, you go to Hadoop and then you say 8000 and then file browser, and okay, use students, and then we say data. All right. Now here there is a folder called data, and in this we are trying to load NYSE daily. You can see it has got these fields which are tab separated, and that's exactly what we are also trying to do. We are saying create a table with these columns. We are saying create a table called stocks with these columns, and our data is separated by tab. Now let's have a look. Oh, so let me just remove the tabs. Tabs is causing a little concern. It is trying to autocomplete. All right. Now if you see select star from stocks, you can see this. So we were able to successfully load the data. It is just that we are trying to load this while the data is different little bit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. New York Exchange Daily. I say, okay. All right. Describe stocks. And there is something called describe formatted stocks, which shows you more details into the data which is located. Okay. Or let me just create another table. Select star from stocks 1. Okay. Now the next step in our whole process is to, why, oh, I got it, why is this the way it is? So we say drop stocks. Alright, now we have all of this information. So it says that return code 1 from Hive Java net URL. Oh, it requires that absolute path. So we say user student. That's all. Why? So it says just a second. User student data. This is the one we're talking about, right? User. Yeah, this is correct. Select star from stocks. Let me just see why it's not giving the correct result. Drop table stocks 1. Select star from stocks 1. Exception. HDFS user student data out failed with the exception not a file. Uh-huh. This is strange because I know for sure DFS minus LS. Yeah, it is there. This is correct. Just give me a minute. There would be some code, some problem somewhere. Create external table. If not exist, call stocks. Select star from stocks. Oh, it's working now. No, stock old one it is. Drop stocks. Alright. So users student data out. Okay. We'll see. There's something wrong with the file system. Don't worry about that. Yeah. So external table is more or less like a link table in SQL Server. All right. So okay. All right. All right. So let's try to load the data, and there's something called partitioning before we move on to partitioning. Okay. All right. All right. Okay, so are there no concepts of indexing in Pig and Hive? No, there are no concept of indexing in Pig and Hive. The closest to indexing we have is in the form of something called partitions. Okay, in the form of something called partitions, and that is how the Hive is organized. Okay, now I'm just trying to locate couple of examples which I had done earlier. Now, all right, so we have got, so the way we have external table in which we can define a table, load the data into table, and then start using it. Okay. Similarly, we have got, I mean, partitioning of the table. Horizontal partitioning of table means a table could be loaded from different sources of the data. Okay. So when you are defining a table, you can basically define one more column on which the partitioning is supposed to happen, and then you can start loading the data. Okay. Let's say let's say we have got a table called employee. Okay. 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 Now let's just try to understand this part. So let's say we have got a file called Sandeep 10 and BTech. So this is the employee table. All right. Yeah. So I'll share that modified one quickly. Okay. But before that, let me just go through the horizontal partitioning. So we'll go through the hands-on exercise at the end of the session also once more. Okay. So let's have a look at what does it mean by partitioning partitioning of a table. So let's say you have got an employee table. Okay. And this is your file, comma separated file. Okay. Now you created an employee table with name and salary and then degree. Okay. And you mark it partition by qualification just for the sake of it. And so you load this data into the employee table and say that partition is qualification equals to 1. Okay. Similarly, if there is another data, the employee 2, which refers to qualification 2, you can load that data also. And so in your table, the data from both the location will be present. Okay. The in your table, the data from both the places will be present. Okay. And you can always say show partition of employees, and you can when you select from employees, the data from both the sources, the employee 1 and the employee, will come into place. And the data actually is going to be stored in the way in a single place. Okay. So qualification is not there in that file, in this file. Qualification is not there. But while you are loading, you are mentioning that this particular data, the amp, belongs to qualification equals to 1. The amp 1 is belongs to qualification equals to 2, and so on. And internally, when the hive is going to create the table for you, it is going to create multiple folders so that when the user is asking for qualification 1, it doesn't have to query the whole data. It will query only one part of the data. Okay. So it, okay. Yeah. So this is, Malikram, this is the closest to what Hive can go for the indexing. So this sounds like index, but it's basically a partition. So you can add as many as qualification here based on what data type you defined for qualification. Okay. You can add as many as, partitions. All right. We'll go through the examples of each and every one again in the next session. All right. Don't worry in case in case something is not very clear. Also, just to note that the external party, there is something called external partition table, which is essentially a table. The partition is located externally somewhere like S3 or some HDFS or somewhere else. Okay. And yeah, I think a better would be, all right. So, okay. All right. I think let's take up the rest of the session tomorrow. Okay. Let's take up the rest of the session tomorrow. All right. And because it seems like it's too much for today. Yeah. All right. All right. Yeah. I think it will be better if we take it up tomorrow morning instead of today. Right. Okay, then we'll continue our discussion tomorrow from where we are leaving. Yeah, because it seems that it is too much for today. All right. Bye, Vishnu. Yeah, yeah. We'll share this presentation. Yeah, yeah, yeah. We can go over examples tomorrow itself. Don't worry. All right. All right. Thank you, Malikram. Thank you, Anna. Thank you, Silpa. Have a good day. Thank you, Abhishek. Bye bye.